In theory, hopefully we got good at solving algebraically by, what was the other algebraic method you learned last time? It was called, well, this one's we're calling elimination. The other one was eliminating a variable, but we called it doing that by substitution, right? So there's two different algebraic methods. Both of them are eliminating a variable, so I know that maybe this is misleading calling this one elimination. Sometimes if you were to try and look for this method on the internet, you'd probably have more success calling it the multiplication addition method. Okay, solving algebraically by multiplication addition. If you're to look online for some help or whatever, that's probably a better thing to put in there. I think the pictures help here. Maybe the situation we can look at in a second, but let's look at the pictures here. Last time when we were doing substitution, we used two pictures like this and saw how we could combine them together to figure something out. This diagram, you got two diagrams here, right? You have two of these cones and three of those blocks add up to 17. And we have one cone, one block equals 7. You could do it by substitution if you wanted to, right? Because you could take this. Substitution would be getting one of these things by itself, like you did last time. Like you could put in real life it's hard to do this, but you could put the cone over here and make it an uncone, whatever that is, like a balloon that, I don't know. I mean, something that is the opposite, make it negative on the other side, and then substitute that in. But there's another method that you can use if you have two equations here representing this. Do I have pictures on this side? I do, I think. How do you know this? Where did it go? Maybe we'll shrink it down here so we can see it. That picture right there, from the original two pictures, how do you know this is going to balance? How does this come from those original pictures? If you're saying, how do you know that's going to balance? Yeah, exactly, right? This one cone, one cube is 7, so two cones, two cubes are 14, right? Once you do that, okay, once you accept that that is possible here, then if you put those two side by side, this is the original first equation. This is the new second equation. This is like 2 times equation B, right? It's the original one times 2. It's just doubled everything on the second equation, right? Go back up there. It's taking B and multiplying it by 2, right? If it's balanced now and you say times 2 times 2, it'll still be balanced if you double everything on that side. Okay, now you might still say, how does that help? Make this big again. How does that help? If we have those two equations here, why does that keep happening? How does that help? What can we do now? How could you use these two to create a single equation from those two that only has one variable? Remember, the goal is to create a single equation that only has one variable. If you know those two things balance, what else can you figure out? If you know 2 cones, 2 blocks are 14, and you know 2 cones, 3 blocks are 17, what do you know has to be true? You're not sure? Do you want me to review that for you? 2 cones, 3 blocks are 17. 2 cones, 2 blocks are 14. What can you figure out? You can figure out one of them now, right? 1 block is 3, right? Try to draw it here. 1 block is 3 grams. Now you might be kind of doing it in your head saying, well, this stuff, I'll just kind of replace this, all that stuff with 14. Or you might just say, if I subtracted that from that, right? Basically what you're kind of doing is saying, if I subtract all of this stuff from here, right? If I subtract 14 from that, I get 3 left. You're doing it by subtraction. You're combining two not by substituting one into the other. You're doing it by subtracting. You're saying if you write it with symbols, right? If you use the letter C for, I guess, cubes and cones, that's not good. We'll use this as X, and this is Y. If we have the first equation would be 3x plus 2y equals 17. The second equation would be 2x plus 2y equals 17, equals 14. If you subtracted that, if you subtract those things, this minus this is 3. 3x minus 2x, what does that leave you with? Just 1x. And then 2y minus 2y, what does that leave you with? Nothing, right? There's no y's left. You can eliminate one variable by subtracting or adding equations. That's the concept that's involved here. Adding or subtracting, and sometimes having to multiply first to get rid of things. Okay? Can we have a look at the first example? Again, these aren't in the textbook. There's some like them in the textbook, but what is it happening here? Okay, so let's look at that first one there. I set this up so you could do it on your own. I'm not sure if some of you already tried that or not, but here's two equations. You could do it by substitution. Substitution would be as if you got one of them by themselves. Like if you took, say, this one, and you got x by itself, and you put this on the other side. This is what we did last time, right? If you change that to, so don't write this down here, right? 6 plus y, and then if you said, I'm going to substitute that in for x here, that's what we did last time. This is something kind of different here. If you have two equations that have x and y on the same side, sometimes this is going to be easier. If you notice, this one says plus y, this one says minus y. If those were two separate balances, but I combine these together, if I add all that stuff together and all that stuff together, it should still be balanced, right? If that balances and that balances, if I piled it all together, if I put all this stuff together and balanced it with all this, it should still be equal, right? What do I get if I add all that together? 3x, and how many y's do I have? Nothing, right? It's gone. And I got 39 here, right? Okay, if you add the two together, the y terms add to 0 here. Y terms will add to 0 because there's a plus y and a minus y. You've gone from, remember I told you here, you have two variables, which we don't like, right? But now you got one variable, which you can solve, right? As soon as you have one variable, you can solve it, and you end up with x is 13. It's the same as the other method in that you find the variables one at a time, but it's different how you go about finding them. Now you can solve for the other variable two ways. Okay, now find y. You have two methods. Here's your two methods. To find the other equation, you could do what you've always done. Once you have one variable, how can you find the other variable? Once you know that x is 13, how could you find the other variable? What's one way you could do it? Starts with S. Substitute, right? Substitute 13 for x. So in other words, you could take either one of those equations and put 13 in there for x. So you could say x minus y equals 6. You could say 13 minus y equals 6. Y is 13 minus 6, so 7, right? And so you'd know your solution is 13, 7. That's one method, right? One method is substitute. The other method is going to be, you could just go back and do something and add the equations again. Okay, the other method is use addition again. We added these two to try and eliminate the y this time. It happened that the y got eliminated without us needing to do anything. We didn't have to multiply either one of them. If I took these two equations, but I wanted to make the x's disappear, how could I do that? What could I do if I wanted these to disappear? Those don't match up nicely, right? They don't cancel out nicely. But what if I took the first one and left it alone? But what if I took the second one now and multiplied it by -2? What equation would I have if I multiplied that by -2? If I multiplied each of the things in the equation. -2 times x, I'd have -2x. And -2 times minus y, what does that give me? Plus 2y. And then if I did the other side times -2, -2 times 6, -12, right? If I've labeled this one equation A and this one equation B, this is A, this is -2 times B. Why is that something that's going to be helpful here? What happens if I add those now? What happens? What do you notice happens with those two things? They cancel, they disappear, right? That adds to nothing. What does this give me? 3y equals 21. If 3y is 21, what's y equal to? 7. You divide by 3. For this, there's two ways you can go back and find the second variable. You can either just do substitution, the way you did before, or you can go and try and just add them, multiply and add them again. The textbook and a lot of places they call this elimination method. But again, you might also see it called the multiplication addition method. Okay, so I'm going to leave that for a second here. We're going to go to the next example. Okay, let's try doing that. Okay, I tried to put the titles on here to help you. This is solve a system by elimination where one equation needs to be multiplied. If I just added these the way they are now, what do I get if I just add those the way they are now? If I add these together, I get 7x, what do I get? Plus 2y equals something. Does that help me? Doesn't help me. You haven't eliminated a variable, right? You have to multiply one of them first. Which one would you suggest is one that you could multiply and get something useful out of? You got to decide, are you going to try and eliminate the y's, or are you going to try and eliminate the x's? I would probably eliminate the y's here because they're opposite in sign already. They're already opposite signs. If I want these to cancel out, you got 3y's. You need the second thing to be -3y's here. So what do I need to multiply this by? If I take that second equation and I go times 3, what does that give me? 15x minus 3y equals 51. The first equation I'm just going to leave alone. I'm just going to put this here. 2x plus 3y equals 34. So this is, we'll call that equation A. We'll call this 3 times equation B. Why does that work now? If I add them now, what's going to happen? I have 17x. But what happens to this? This is the key here. Why does that, what happens to those two terms? Cancel out, you got nothing, and you have 85. Okay, so remember, two variables down to one variable. You've eliminated a variable, right? Once you eliminate a variable, then you can solve it, right? What's x have to be there? X is, if you divide that, what do you get? I'm thinking you get 5 if you divide that. Okay, so you got to multiply by something to make one of the things match up. The easier thing was to make the y's match up. You could have made the other thing match up, but you'd have to multiply both equations, so that's the next example. What is our option here for finding, what's the quickest way to find the other variable here? Probably in this case substitution. We substitute 5 in, put it in for x. Which equation do you like better? I'm thinking the second one. I'm going to take 5x minus y equals 17 and put in here a 5 for x and then solve it. We got 25 minus y equals 17, so y is 25 minus 17, or y is 8. If you want to check whether you're right, take those two numbers and put them in and check, right? You can always check them in here and see if it works. Check it in that equation, check it in that equation. All right, last thing here is if you need to multiply, sometimes you're going to have to multiply both equations. Both equations need to be multiplied. Let's look at this and decide, why do both equations need to be multiplied there? The previous one we had 3 and 1. You can make them match up by just taking the second one and multiplying by 3. If you have 3 and 1, you can just change that one. Change that, multiply that by 3. But what are our coefficients here? Why doesn't it work to just multiply one of them here? We have 3 and a 2. Can I multiply one of them by something to get the other one easily? I guess you could. You could multiply this by 1.5 if you want, but that's not very convenient. Or if you want to make this match up, you'd have to multiply by something. It's easiest if you look at it and say, if I want the y's to match up, what can I multiply by here? If I multiply the first one by 2, and I multiply the second one by 3, I'm actually going to times it by -3, because then the signs will be right if I times that by -3. So the first one is going to give me, this is 2 times the first equation. What do I have? Instead of 4x plus 3y is 35, I got 8x plus 6y equals, what's the number on the other side? Got to be here. 70. And then if I do the second one here, we multiply by 3, -3, you're going to get -21x minus 6y, and then whatever -3 times 32 is, -96 or something. Then you're going to get somewhere with it. Okay, so the key is multiplying there, right? The first one, 2 times a, and this is -3 times b, the second equation. If I add it now, what do I get? If I add the 2, remember, if one side works, then if each of those are balanced, then when you add them, they'll still be balanced. This is going to be giving me -26. What does this give me? -13. -13x equals -26. If I divide that by -13, I get +2. +2. And then if you take that and put it in one of those equations, right? Like if you take whichever one you like better, 4x plus 3y equals 35. Take that and put it in there. Right? Replace this thing with 2. Okay, if you work it out, 3y equals 35. Oops. Try again. We got 8 plus 3y equals 35. 3y equals 35 minus 8, whatever that is. If 3y is 27, y is 9. So your solution is 2, 9. That's elimination. Okay, that's that other method. the second of your two algebraic methods. Okay, it involves multiplying one or both of them and then adding them. Sometimes you have to multiply by a negative number. The other stuff that's in here is just quickly getting some practice at doing this. Okay? So we got some time right now. If you can do the your turn questions and then some of the other stuff in here, remember we're trying to be efficient about this. If you were to go through and do the your turn questions and then these ones right here, I'm sure you'd be fine with this method. There are 3 questions in the textbook if you want, and then there's an extension thing, but at some point likely I want you to look at this. We touched on this at the beginning when we started this section, or this whole chapter, number of solutions, but this is a really short little section that you can, if you look at those 2 pages, it'll be obvious what this is all about. Okay, but first of all, nail down elimination, maybe in the next 20 minutes or so, and then start looking at that last section, okay? Can you get going on that right now, please?